Hello everyone. So we'll see a very important algorithm today, which is Kadane's algorithm. So what we need to find out is a maximum contiguous sum array. So the problem statement is that given an array which contains both negative and positive integers, you need to return the sum of a sub array which has the maximum sum basically. For example, suppose this can be our sub array that has the maximum sum, so you need to return that sum. So of course the naive approach will be to find out all the sub arrays, calculate their sum and return the sum which was the highest, but that will take the complexity of O of n square. So we won't go for that brute force approach. We'll rather choose this Kadane's algorithm which does this task in simply O of n, because it just have a one loop iteration. So coming into that, let's jump into the algorithm. Here we will keep track of two variables. One is maximum so far. That means if you are at this position, suppose what was the maximum sum you have seen till now, that will be stored in this maximum so far. Okay, so we'll see how to update that in the algorithm. The next is maximum ending here. That means, so don't get confused. Maximum so far means that in this array whatever you have seen, maximum ending here means including the current element. What is the maximum ending here? Okay, so that will be simply the maximum ending what you have seen just before that plus the current element. So let's jump into the algorithm. So firstly you will set maximum ending here to 0 and maximum so far to int min. Why int min? Because you just want whatever element comes, it should be a greater than this maximum so far, so we'll set it to int min. So maximum ending here will be 0, this will be int min, right, in the beginning of our algorithm. Then we'll iterate one by one and we'll update maximum ending here, which is this element. So basically we'll add maximum ending here with whatever current element we have in picture. Okay, so these are the two important steps. That is basically how we'll update these two variables, right? So if maximum so far, that means whatever maximum we have seen in the array is less than maximum ending here, we will update maximum so far to maximum ending here. Why? Because maximum so far should contain whatever the highest we have seen till now, right? So if maximum ending here is greater than that, maximum so far should definitely hold that value. Then if maximum ending here is less than 0, suppose we have reached a point till here and maximum ending here is -3, then definitely we need to set it to 0. Why? Because whatever sum we are going to get after that, we will not include this -3 because we don't want to hold the sum which is less, right? So if this turns out to be 0, we will update maximum ending here to 0. Now let's jump into the algorithm. For initially we have I is equal to 0, maximum a of I is -2. So first step is updating maximum ending here. So this will become 0 plus -2, which is -2. Now we will compare if maximum so far is less. Of course it's less because it's set to int min. So this also will be updated to -2, right? So now we'll go to this step and see if maximum ending here is -0. So this is 0, so we need to update it to 0, right? So this will be updated to 0. So why we are doing that? If you think about logically, if you want to find maximum element here and suppose we are getting some array that amounts to a minus sum, of course we will not take that array in account, right? Whatever element comes after that will be greater, right? So that's why we are removing or setting it to 0. Then again we'll go to the second position. This will be -3. Maximum so far is not less than, because maximum so far now will become maximum ending here now will become -3, right? Because this will be 0 plus 3 -3. So this is of course not less than, so we will keep like this, and again this will become 0. Then again we'll go to 4. This will be 1, this will be 2, and then the element will be 4, right? So maximum ending here will become 4 because the previous was 0, so we'll just do 0 plus 4. And maximum so far is less, so we'll have to update this as well. Then again our pointer will go to this position -1, that is 3. Here this is -1. Maximum ending here will become 3 because you are just adding, and maximum so far is not less than that, so we'll just keep it like that. Then again our pointer will go to -2, so this will be 4 -2. Maximum ending here will become -2 plus 3, that is 1, right? This will still be 4. So again this will be now at the 5th position, that is R1. Maximum ending here will be 1 plus 1, that is 2. So still maximum so far will be 4, no brainer, right? Because it's still the maximum. Then the last element, now it will go to 6. Our element will become 5. This will be 2 plus 5, which is 7, right? So now this will be changed to 7 because this element was greater. So now we are at the end of the array and we have found the maximum so far. So we will return this value, right? And also if you've seen this array, right, you will see that this is the array with the maximum sum. So that's what our algorithm does. So now we'll quickly jump into the code and try to see how we have done the coding. So this is the Geeks for Geeks prompt for Kadane's algorithm. You can see that it is asked in so many companies. Of course, this is a very popular algorithm. So just try to code whatever algorithm we have seen till now. We'll define two elements, maximum ending here and maximum so far. So max is 0 and maximum so far is set to int min. Iterate it for all the elements. Contains, this will contain maximum, so maximum ending here, right? So we'll just have the maximum ending here and add the current variable. Then we'll check those two conditions which we have seen. If maximum so far is less, we'll update maximum so far, and if this maximum ending here becomes less than 0, we'll update it to 0 and simply return maximum so far. So let's just try to submit it and see if this code works well. Right, so that's it.